What's going on, everybody? Welcome back to my YouTube channel, Richard on Data. If this is your first time here, my name is Richard, and this is the channel where we talk about all things data, data science, statistics, programming. So subscribe to my channel for all kinds of content on that kind of good stuff, and hit the notification bell so YouTube notifies you whenever I upload a video. So anyway, a couple weeks ago, I did a video on the state of AI and machine learning in the year 2020. The company Appen did a report on all that good stuff, and I went through that report in some pretty good detail. I thought there were some pretty interesting findings for it. So check out that video if you haven't already. I'll have a link in the description as well as a card up above. But anyway, so I'm scrolling through LinkedIn over the weekend, and then I find out that Anaconda, of all organizations, actually just did a 2020 State of Data Science report. So now I feel obligated to go through this one as well. Except it's not really an obligation because I love going through this kind of stuff and reading it and sharing this kind of stuff. So again, not really an obligation. So we're going to go through all of this because I think it's super important for people who are current data scientists or who are aspiring to get into the field, just to be aware of what's happening and what the current trends are. So yeah, before I do all that, the usual asks that I do in all of my videos. Again, subscribe to my channel if you haven't already. Hit the like button to this video because that helps my content reach a larger audience. I have a Patreon link in the description of this video. If you guys are willing to support me that way, that would be massively, massively appreciated. And also, to those of you who've been subscribed to me for some time, this is the first time that I've done a video in this style, so streaming what's going on screen while I talk over it with my face in a corner. So let me know how you feel about this style of video, because usually my videos are much more heavily edited. Quite frankly, this kind of style of video is easier to do, so yeah, let me know what you guys think. I'll be very curious. And yeah, so without further ado, let's step through this report. Again, it's from Anaconda. On their website, this is freely available, and I'll have a link in the description to this. So it's about 38 pages long, starting with the methodology here. They surveyed 2,360 people from more than 100 countries. This was fielded from February 12 to April 20 of 2020. So as far as the US is concerned anyway, we got the major outbreak of the illness about halfway through this period. So I don't know to what extent that might influence results here, but that's certainly something that's been affecting the economy as a whole and just the world as well. Respondents were recruited via social media and the Anaconda email database. So right off the bat, that probably produces a little bit of selection bias as well as response bias. Because you're getting a very specific kind of individual who's recruited via social media and actually responding to this kind of thing. I can't think off the top of my head in what way that influences or creates problems with the results here necessarily, but probably just something to be aware of. As far as where the responders are coming from, again, it's 2,300 people. A plurality of them are coming from North America. I know I have an audience that's in India. My guess is, as far as the responders in Asia, a lot of them are probably coming from India. Some of them are probably in Japan and other countries as well, but I'd bank on a number of them probably being in India. Now, as far as where they're coming from, education-wise and degree-wise and just job level-wise, 30% of people hold a bachelor's degree, 36% hold a master's, 1 in 5 hold a PhD. Now, I've seen things indicating that as many as 90% of data scientists hold a master's degree or PhD. And granted, as you see over here, not everybody who are responders here are data scientists, so that probably has something to do with that. All that to say, I'm surprised even 30% of people in the survey here hold a bachelor's degree. I'm surprised it's not smaller than that, and I'm surprised you don't see a bigger chunk in the master's and doctorate degree columns. But anyway, the biggest bulk of people here are senior levels in their organizations, followed by there are a lot of people who are entry level, managers, owners, executives, C-level types. And as far as the job role kind of thing goes, again, the biggest chunk here is data scientists, but there's a decent representation here from academia. Like the next biggest chunk is actually students and professors and instructors, followed by developers, analysts, researchers, and engineers are on here too. As far as the industries, you've got a big representation from technology, consulting, healthcare, and these numbers don't add up to 100%. So you've got a representation here from academia as well. I'm assuming that's a big chunk of the 23% who aren't included here. As far as where people fit inside their organization, for those of you who are unfamiliar with the term Data Science Center of Excellence, broadly speaking, that refers to a central cross-functional kind of data team. So that's going to be our biggest chunk here, followed by data professionals working in R&D, then a specific line of their business like HR or marketing. A lot of data professionals work in IT. So then moving on, naturally there's a big data science life cycle. Now, as far as where people are spending their time, this is interesting. So broadly speaking, data loading and data cleansing, you can pretty much file that under the category of data wrangling. And you guys probably all know the old joke. It goes that 80% of a data scientist's time is spent cleaning data, 20% of their time is spent complaining about cleaning data. So I'm actually surprised these two together don't actually make up more than 45%. And I mean, obviously the 80% thing, that's a joke. So I wouldn't expect this to be 80%, but I'm actually surprised it's only 45%. Data visualization is the next big chunk here. 23% of time when we group model selection and model training and scoring together. 23% of time together goes to modeling tasks. I'm actually surprised it's not significantly lower than that. 11% of time is spent deploying models to production. Now, this leaves out some more exploratory type stuff, like maybe if you're producing like reporting, summary statistics for data. I don't really know what category this falls under. My guess is either data cleansing or data visualization, but I feel like that's a chunk of time for a lot of data professionals that isn't really represented here, so that's pretty interesting. But again, you can't escape the fact 45% of people's time is going to this kind of thing. So probably, hopefully in the future, people try to figure out how to reduce this chunk, because that's still, I mean, there's mixed feelings I have here, because this is not stuff that a lot of people want to be doing necessarily, but it's also orienting yourself with expectations. So academia does sell a vision of data science where all this stuff down here takes up more of your time. So part of it is an expectation kind of thing too. So I don't know, those are just broadly my thoughts on all this. This is a pretty interesting one, how often these languages get used. The green category is always, followed by light green is frequently. This navy-ish color is sometimes. The biggest thing by far and away that people are using is Python. That's 47 plus 28%, plus 16% is 91%. So 91% of data professionals from this survey are using Python. And again, this is maybe one of those instances where there's some bias going on here, because Anaconda is, broadly speaking, an R and Python distribution platform. I don't know if that's creating a bias here. Either way, though, R and Python, they're the runaway leaders, but Python is running away ahead of R. Because with R, you've got 10% plus 17% plus 20% is 47%. So that's a very distant second of people who are using R. And that's pretty consistent with findings from things like the TIOBE index or Indeed job listings. All of that indicates there's been a big drop-off since 2018 of people using R. So no surprises there. Now, I talked about in my State of AI and ML video that people may have been using C# and C and C++ more in the data world. Now, this doesn't indicate that because we've got 12% for C#, 23% for C or C++. So my guess is because Appen, with their State of AI and Machine Learning report, they seem to indicate that more data professionals were using those languages. So my guess is for things like deploying to production, there's more emphasis on these languages compared to R or Python. Granted, you can obviously do that with R and especially in Python, but my guess is that's to the extent people are using C# and C and C++, they're using them for deploying to production. So for those of you who they know R or Python or both languages, but you don't know any of these languages, based on this, I wouldn't worry too much. More on the toolkit. For the most part, it seems like data scientists are picking their language of choice based on convenience. So most useful tool for their need, followed by speed of innovation. Most economical option is next. I don't know if that means economical, like it's efficient from a timing standpoint, or if it's most economical from the pricing to their organization. Either way, it's largely a convenience kind of thing. Getting to production is a next big topic here. Naturally, this is a business differentiator in data science in some industries, if not an absolute requirement in other industries. So when you ask this question, what roadblocks do you face when moving your models to a production environment? And granted, these people here can select multiple options because these percentages, they're not anywhere close to adding up to 100%. But the answers definitely vary from data scientists to developers to system administrators. Probably, naturally, because they're working on different parts of the overall process. But data scientists say their biggest roadblock is managing dependencies and environments, followed by a skill gap in their organization, followed by meeting IT security standards. So with this one, with managing dependencies and environments, I really wonder how much of that is a educational thing, like how much universities are actually teaching this kind of thing, because that is more of a computer science-y kind of thing, at least to a certain extent. Some of it is probably at the organizational level too, like the data science team and the organization not understanding how to make all these things work together, like the prototyping phase and the deployment to production phase, just kind of making that more of a seamless transition. So how much of that is more of an organizational education kind of thing? The very next big category that people are saying is a roadblock is a skills gap in their organization. I can say from personal experience with healthcare, meeting IT security standards is a pretty big one. Just because there's all kinds of privacy concerns that I personally experienced with healthcare that can prevent you from taking things to the level that I know a lot of people want to. I'm certainly not an expert on data security. That's not something that happens to be in my personal wheelhouse a lot of the time. Based on this question here, on a scale of 1 to 5, how concerned are you about managing security and vulnerabilities and open source tools? When you ask people this, system administrators, business managers, product managers, and people who are in the data engineering side of things, they seem a lot more concerned about this than data scientists are. Look at professors and instructors and researchers way down at the bottom. That's really not something they seem to be thinking about on the day-to-day, so that's fascinating. Now, speaking of which, we've got to this question here: how do you ensure open source packages used for data science and machine learning meet enterprise security standards? So check this out. Among those who know their employer's approach to security, 30% report that they have no mechanism in place to secure open source pipelines. So that seems very, very problematic to me. And again, I just admitted, that's not something that's the first thing that I'm necessarily worried about from day to day. But especially in industries like healthcare, where if you have security breaches and privacy concerns and big privacy problems, this results in huge fines for the organization. And the bigger the scale, the fine becomes enormous very quickly. So This to me looks like this could be a big scandal that happens in the next 1 to 5 years. This is the equivalent. This could turn into something like the next Enron scandal that happens specific to the data science world. This could happen in the next 1 to 5 years and just change the way that organizations do data science in general. I don't know. I mean, this is possible. I could see something like that happening. Maybe not. We'll see what happens. This next question: in your opinion, how effective is your team at demonstrating the impact data science has on your company's business outcomes? This is polled by industry. 71% of people in consulting say most of the time or almost always data science is having a big impact on business outcomes. And that's good because, at least in theory, consulting should be heavily data-driven. Technology's doing pretty well. If we look towards the bottom, we've got education, government. Healthcare is dead last at 34%. And again, I've worked in healthcare before, so this isn't massively surprising to me. And again, I could speak from experience here that there are a ton of barriers in healthcare to driving serious business value. You have to convince actual providers, at least if we're working in healthcare with providers, putting aside payers for a second, although it's all heavily interrelated. Providers can be very set in their ways. They've been practicing medicine for, at times, 20, 30, maybe even 40 years. They're set in their ways. They don't want to change what they're doing because some model tells them to do so. And again, healthcare, you've got all kinds of security and privacy issues there, which, again, these are going to be big roadblocks for things like model development, getting data, deploying things to production, all that stuff. So yeah, healthcare's got some pretty serious problems here. And I think it really says something about your industry that you're not, data science is not driving business there. It's driving business even less than in government. So that's really, really telling that you're making less progress than you are even in something like government. This one is pretty timely because I just did a video on data scientists quitting their jobs. So these categories up top are currently looking and planning to leave the organization within 6 to 12 months. So file that all together under people you can expect to leave the organization within the next year. Now, I'm not an expert on this kind of thing because I'm not involved in my personal organizations. What's the word I'm looking for? Retention, like keeping people around in data science. But right off the bat here, this doesn't seem massively alarming to me. Like, only 29% of people who are working in R&D, they plan to leave in the next year. As far as the Data Science Center of Excellence is concerned, Only 36% of data professionals plan to leave in the next year. So again, we keep talking about there are a shortage of data scientists out there, which means multiple jobs are competing for the same data scientists, essentially. And again, with the illness going around, maybe that landscape changes a little bit because the illness has hurt the global economy to a very great extent. But again, I don't know what numbers HR professionals look at and they get scared at, but 27 to 36% doesn't seem massively scary to me. Again, we're talking about people who are in very, very heavy demand here. So again, this doesn't seem that crazy to me. The skills gap between universities and what enterprises lack. Now, this is a super fascinating one. So they asked the questions about what students are learning and what universities are offering. So these two should be heavily overlapped, and to a great extent they are, right? We've got Python and machine learning are in top categories here. So are data viz, probability and statistics, deep learning and advanced mathematics. So I guess they just kind of asked the question a couple different ways to get different answers. But then as far as what enterprises lack, they're lacking big data management and they're lacking engineering skills. And these things aren't showing up on the big categories for what students are learning and what universities are offering. So look at that. We have a gap between what universities are teaching and what enterprises say they're lacking. There's no big surprise to me there. The fact enterprises say they're lacking deep learning and machine learning, that one's interesting to me. I'm really curious if enterprises are lacking more of the theoretical knowledge kind of thing that goes into these things, or they're lacking more of the knowledge about how to get these things into production and to actually see value out of them. Because it seems to me like those are two very, very distinct things. And it's interesting that advanced mathematics is also on this list of things enterprises say they're lacking. So that could indicate when people say they're lacking deep learning and machine learning, that's kind of the problem. I don't know. I kind of feel like I need to know more about this because this brings a lot of questions to mind for me. This question here about what's the biggest obstacle to obtaining your ideal data science job. The biggest thing is experience. That's not surprising in the slightest to me. Again, I make fun of on my channel all the time these jobs. They don't know what they're doing. They list 20 different technologies that people need to be familiar with. That just indicates that they don't know what they're doing. But I understand too, people need to get their foot in the door. They need to kind of know what they're doing before they can get hired too. So is the university preparing them? Is it giving them the skills in Python and R? This here, I mean, that looks optimistic, and I'm glad that universities are offering Python and that students are learning it, because it seemed in the past like academia had more of a push towards R. But as industry goes to a more Python-based direction, it's good that universities seem to be doing that as well. Sorry, I'm skipping around all over the place here. Technical skills is an obstacle. Skipping ahead a little bit here to the biggest problems to tackle in the AI and machine learning area. Again, impacts to individual privacy were a big thing. Again, that could turn into a big scandal in the next few years, I think, if that many data professionals are not doing anything about it. Now, this next one, as far as social impacts from bias in data and models, just a little bit of an overview on that. And there are tons and tons of examples from that, but let me just come up with a simple, easy to explain example of that for those of you who haven't thought about this issue before. So let's just say you're working on something like predicting for a customer base how likely people are to default on a loan. So it could be the case that you have your black respondents, they are more likely compared to your white respondents to default on a loan. So let's say you're training a model and you're using race as an input to your model. So that might end up making your model more accurate just based on the sample that you have. But it's going to end up as a very vicious cycle kind of thing where as a result of that input, which was used to make the model more accurate, you have more black people compared to white people being declined loans because this model says they're more likely to, or the model is saying the black recipients are more likely to default on the loans. So that's just an example that I just came up with just now. I'm sure there are tons and tons of examples out there, but yeah, that's a pretty big thing, which it's easy to use a little bit of imagination and just see where that could turn into some pretty huge problems. Fairness and explainability are big issues. That's especially the case with things like, let's say in that example that I just used, there's no explainability that's going on whatsoever. The impact that race has on how the model was put together. I mean, if the model is a neural network, which is already a totally black box model, yeah, forget about it. Forget about trying to go before the broader population and public and explain that. Like it's very easy to see how that's going to cause problems. As far as the data science teams working on solutions to address data bias or model explainability, seems broadly like people are pretty slow to address this kind of thing. Fairness and bias mitigation, only 38% of respondents say they've already implemented a solution or they're planning to within the next 12 months. 54% of responders say they've done so. So looks like people are a little behind the ball on that one. So again, maybe this turns into another big scandal within the next couple years. It's very possible. So we could see some big changes to the data science field based on these kinds of issues in the next few years here. Again, there seems to be a lot of evidence of that. Looking ahead, and this is kind of just a summary overall to this report. Value realization, getting data science outputs into production will become increasingly important, requiring leaders and data scientists alike to remove barriers to deployment and data scientists to learn to communicate the value of their work. Yes, so a lot of this is just getting yourself familiar with the business environment as a whole, being able to communicate that, and getting educated on the actual element of deploying models into production. It seems like to a great extent that's something that's not getting covered a lot within colleges and universities. So that's a little bit problematic, but that's important now, and it's going to be even more important as we move into the coming years of this decade. Integrating open source technology. So we've got organizations should take a proactive approach to integrating open source solutions into the development pipeline, ensuring that data scientists do not have to use their preferred tools outside of the policy boundary. So this gets back to some of the topics earlier here about making sure people aren't switching from one language to the other. Let's actually be able to deploy models into production using R or Python. Like switching from one tool to another is grossly inefficient. So hopefully there's not a lot of that going on. And to the extent we can use those open source tools like R or Python to deploy models into production, that's a good thing. Hopefully we can do that. Talent development, acquisition, and retention. That seems incredibly broad, and I feel like each one of those three could be its own slide here. They even say it here, the talent issue has numerous dimensions, and the most successful organizations will address it from multiple angles. Yeah, as we saw before, there is a gap between what people are learning in universities and what enterprises are requiring. It's actually not as horrible as I thought it was, but hopefully universities are taking note. I think the fact that a lot of universities are developing data science specific programs. That's an extremely good thing, and I think in a lot of universities, that makes sense for people. And I've said in a lot of videos, having a strong statistics base is important, but so is knowing programming and deploying models into production. These are important things too. Employers should look beyond compensation and design holistic data science talent retention strategies focused on helping data scientists gain experience articulating the value of their work. Yes, absolutely. Data scientists should have some degree of understanding of how business operates and how data science helps these businesses generate revenue. I feel like that's kind of a gap with a lot of colleges and universities. So I'm a big fan of internships because it'll just bring a lot of much needed perspective. Say you're like in a master's program, you have an internship in the summer after your first year, and then you come back. I think when you go into your second year, having done an internship in the middle there will bring some really helpful perspective. And they say it here, finally, employers should take seriously the business value of cross-training. In the short term, organizations can cross-train and upskill domain expert employees in modern data science methodologies and tools to improve outcomes. Yeah, I mean, I think the career trajectory for a lot of data scientists involves becoming a domain expert, particularly if you've been in the same domain for like 8 to 10 years, and you happen to be extremely technologically savvy on top of that. And I think that's going to be an incredibly lucrative career trajectory and an overall job in general as we move into this decade. Looking beyond compensation is definitely important because, I mean, let's face it, to retain and attract talent in the first place, yeah, these companies, they have to cough up big money, but I just covered this in my video about data scientists leaving their jobs. A big thing which people are citing and complaining about is lack of upskilling opportunities. You have to know a lot of different skills in the data science field. So if you just feel stagnated and like you haven't been learning anything in the next 6 to 12 months, yeah, I mean, you're probably gonna want to leave your job, or at least you're gonna look at what's out there and just really ask yourself some pretty serious questions about if you want to stick around. Bias mitigation and explainability. We see an opportunity for data professionals to exert leadership within their organizations and drive change. Yeah, absolutely. I mean, this is certainly something that should be encouraged. And they say here, we were troubled to find 39% of enterprises do not have a plan to implement solutions for bias mitigation. 27% have no plans to tackle explainability. Yeah, for those of you who are current or aspiring data scientists, yeah, I mean, find opportunities where you're in your organization to address this problem. And I mean, really ask yourself, is this a big problem? Say you're working on a model. Could there be some real social consequences to the work that you're doing? Is the work that you're doing creating good for society as a whole? I mean, really ask yourself that question. Don't just go to your job for a paycheck or to work on cool models. Really ask yourself that question. I mean, I'm a millennial myself. I think my generation, we ask this kind of question a lot. I mean, it's not enough for us to earn a paycheck. We really want to do good by the world a lot of times. Whether we're successful at doing that is a separate question, but yeah, I mean, this is an opportunity to really be a thought leader in your company and in data science in general. So yeah, that wraps it up. Again, I think there's a couple things here which were maybe in red flag territory, like the security stuff and the model explainability and bias stuff. We could see scandals as we move forward, but overall, again, I think the future as we go into data science, it's looking extremely bright. So there's nothing here that was enormously surprising to me, but yeah, this is just a broad, good, comprehensive overview, I think, of the trends that are going on in data science. And yeah, I think I've said my piece, and I'll just leave it there. So thanks to everybody for watching this video. Again, let me know what you think about, really everything here. Let me know if you found anything surprising. And again, let me know if you enjoyed this style of video on my part. Because again, this is really fun and easy for me to make. As usual, again, hit the like button so my content can reach a larger audience. And yeah, then I'll see you guys all in the not so distant future. Until then, Richard on Data.